Hello and welcome to today's eOrganic webinar, which will focus on some recent research on bovine fatty acids. My name is Deb Haliba and I work at the University of Vermont Extension as eOrganic's Dairy Team Coordinator. eOrganic is the organic agriculture community of practice with eExtension, and you can find all of our published articles, videos, and upcoming and recorded webinars on our website at www.eextension.org/organic_production. Today's webinar has been made possible with funding from the USDA NIFA Organic Research and Extension Initiative Program, as well as the Farmers Advocating for Organic program. If you do plan to share the recording or information presented today with others, we would greatly appreciate acknowledgement of eOrganic and today's speakers. So before we get started, I wanted to give a quick overview of the agenda. Our session is scheduled to end at 1:15. Melissa and Caleb will give their presentation for about 50 minutes, and then we'll transition to our question and answer session for the remainder of our time together. Okay, it is now my pleasure to introduce our two speakers for today. Melissa Bainbridge is a PhD student in the Department of Animal and Veterinary Sciences at the University of Vermont. Her research involves working with organic dairy herds that employ grazing systems to optimize the fatty acid profile of milk fat for human health. We also have Caleb Goossen, who is a PhD student in the Department of Plant and Soil Science of the University of Vermont. And Caleb is researching management choices to optimize the fatty acid profile of forage crops. So welcome both Melissa and Caleb, and I'll turn it over to you, Melissa.
All right, thank you, Deb. So today we're going to talk to you about fatty acids from forage to milk and meat. So we're going to start off with some introduction to milk fatty acids, why they're beneficial to consumers and what they are, and then we're going to go into some factors affecting milk fatty acids, and then I'll turn it over to Caleb and he'll give you an intro into forage fatty acids and how to improve them. And then at the end, we're both going to talk about our research. I'm going to talk about a study that we did using pearl millet and collecting milk and seeing what pearl millet did to the milk fatty acid profile in comparison to a diverse pasture. And then Caleb is going to talk about some research he did in improving the fatty acid profile of Sudan grass and pearl millet. So to get into it, fatty acids have gotten a bad rap in the public perception as being very bad for you. I don't know if this is, let's see if that's going to move forward. There we go. So consumers have a bad perception of milk fatty acids because there's a lot of saturated fats. And there was some research done in the 60s and 70s that correlated increased intake of saturated fats with cardiovascular disease. And recently in the media, they have actually reported that milk fatty acids actually have some very bioactive fatty acids and have been correlated with decreased risk for metabolic syndrome, as well as decreased risk for heart disease and diabetes. And other research has shown that saturated fats are actually more benign than we once thought. And in particular, they have found more healthful fatty acids in organic milk. Now, just a note, the difference between organic and conventional is mainly that requirement for organic producers to have 30% of their dry matter from pasture. So the difference that we're seeing in the milk fats is because of that pasture intake, not because of anything in the system. So we have this article from the Huffington Post that in particular is saying that there are more omega-3 fatty acids in organic milk than conventional milk. And of course, there are more omega-3 fatty acids in whole milk than there is in low-fat or fat-free versions. So companies and co-ops are using this as an advertising tool. You'll often see naturally occurring CLA and omega-3 in this Organic Valley pasture butter. You also see over here, this one's advertising as well that there's CLA and omega-3 fats in that butter. And a recent study, 2-year study by Cargill showed that 98% of consumers understand what omega-3 fatty acids are and will choose products that have omega-3 fatty acids over ones that don't, and will also pay more for those products. Another survey showed that grass-fed has the same effect on consumers in that they buy more or choose that product over others. So you'll see often this grass-fed labeled beef, and here this grass milk cheese is labeled as 100% grass-fed. This also has a financial benefit to farmers because this new grass milk program, they're getting $4 extra per hundredweight if they are purely on grass, which could potentially increase the beneficial fatty acids in that product. And there's also maybe going to be some sort of program developed where farmers are paid for their fatty acid profile. Organic Valley is already paying egg producers who have increased amount of omega-3s, so theoretically they could start paying milk producers for the amount of omega-3s contained in their milk. So I'm just going to give you guys an intro to fatty acids so that we're all on the same page, because going forward you're going to need to understand this when we talk about how to improve these in milk. So saturated fatty acids have no double bonds. They're completely hydrogenated. So here we have an example. As you can see, it's just a straight chain. This denotion here of 18,0, 18 refers to the amount of carbons, 0 refers to the fact that there are no double bonds. And over here on this OH end, I refer to this as kind of the beginning of the fatty acid and this as the end. And so our next class is monounsaturated fatty acids. Those have one double bond, as you can see here. That introduces a kink into that chain. And as you can see down here, again, this one has 18 carbons, and this one refers to that one double bond, which comes in handy for the notation of polyunsaturated fatty acids, because those just have 2 or more double bonds. So over here on the right, we have linoleic acid, abbreviated LA. This is an omega-6 fatty acid that you'll hear us talking about a lot today. It has 2 double bonds, and it's an omega-6 because that first double bond comes 6 carbons from the end. And then you'll also hear us talking a lot about alpha-linolenic acid, or that abbreviation is ALA. That's an omega-3, and it's an omega-3 because, again, that double bond comes 3 carbons from the end. So the omega-6 and omega-3 fatty acids, linoleic acid, LA, and linolenic acid that I just mentioned, are essential in our diet. And our body will take those fatty acids and then elongate and desaturate them so that they have more carbons and more double bonds into the more bioactive, longer chain EPA and AA. So the reason that we talk about the omega-6 to omega-3 ratio is because these 2 fatty acids compete for the same enzymes in these pathways. So if we consume more omega-6 than omega-3, then these enzymes are going to preferentially act on those omega-6s over the omega-3s. And these omega-6s are shown to be more inflammatory, whereas the omega-3s tend to be more anti-inflammatory. So as I mentioned, and as many of you have heard, it's very important to keep these omega-6 and omega-3 in a balance in the diet. Right now, our typical Western ratio is about a 15 or up to 20 to 1, whereas our ideal target ratio is a 4 to 1. So sources of those omega-6s in the diet are seed oils, or if we're talking about dairy cow diets, grains. That's where you're going to see a lot of those omega-6s. And sources of omega-3s are canola and flaxseed oils. In human diets, walnuts and green vegetables. In cows, it's going to be fresh green pasture. And fatty fish are also a very good source of omega-3s. And if we're talking about human or cow diets, then fish meals have a lot of omega-3s. So these omega-3s are very beneficial to both human and cow health. For humans, they're very important to growth and development. They've been shown to reduce the risk of cardiovascular disease and improve heart health. They are anti-carcinogenic. They improve neurological function, and as I said before, they're anti-inflammatory. Now, when you feed these to dairy cows, not only are you going to improve the amount of omega-3s in milk fat for human health, but they also have a beneficial effect to the dairy cow. They've been shown to improve reproduction and decrease pregnancy loss, as well as decrease time to conception. They've been shown to reduce methane production. In addition of 1% of omega-3 or polyunsaturated fatty acids has been shown to decrease methane production by 6%. So if you increase the amount of these fatty acids in the diet by 5 or 6%, you can get a very significant reduction in methane production. And they also improve dairy cow immunity. Now, CLAs, that other fatty acid that consumers want to consume and is often used as an advertising tool, that's a very good fatty acid because it's unique to ruminant products. They're a byproduct of modification by the rumen microbes, which I'll get into soon, but you find these predominantly as a source in our diet in ruminant dairy and meat products. So these have been shown to reduce the risk of diabetes. Again, they're anti-carcinogenic and they improve heart health. So how do these fatty acids get into milk fat? Well, first we have our two predominant forages that you find, or predominant fatty acids that you find in forages. That's the 18,2-LA, the omega-6. Again, that one you'll find mostly in the grains. And then the 18,3-ALA, the omega-3 that you'll find in your fresh green forages. So these two fatty acids enter the rumen, and then they're converted by those rumen microbes into CLAs, and then into trans 18,1, and finally into 18,0. And that's the reason that you find a lot of saturated fats in milk when actually the majority of fatty acids in the dairy cow's diet are polyunsaturated fatty acids. It's because these rumen microbes do this conversion of the polyunsaturated fatty acids to saturated fatty acids. And this happens at a rate of about 80 to 90% of the fatty acids are converted into these different products, the CLAs and the 18,0. So only about 10% of the ALA and ALA can escape the rumen unmodified. So all those fatty acids and intermediates are available to the dairy cow for milk fat production and meat production. The one difference you're going to see between the milk and the meat is that in the mammary gland, the enzyme that converts this trans 18,1 into CLA is more active. So you're going to find a higher content of CLA in milk than you would in meat, but you're going to find this fatty acid in both milk and meat products. Okay, so desired milk fatty acid composition, as far as we're concerned, we want to increase those polyunsaturated fatty acids, particularly those omega-3 fatty acids, the main one being that ALA, and we also want to increase those conjugated linoleic acids, or CLAs. And just by the factor of proportion, by increasing those polyunsaturated fatty acids, we're going to decrease those saturated fats. And as I said, saturated fats are more benign than we once thought, but if we decrease those saturated fats, we leave more room for the polyunsaturated fatty acids. And also by doing this, we get a more spreadable butter product. So imagine, you take the butter out of the fridge, and usually you have to let it thaw a little bit to spread it. So if we increase those polyunsaturated fatty acids, we can take that butter straight out of the fridge and have a spreadable product. That's why you see a lot of companies putting olive oil or other oils with a lot of polyunsaturated fatty acids into butter products, because it creates it more spreadable. But we can do that naturally by changing the milk fat composition. So factors that affect milk fatty acids, we have breed. That's one factor that does affect milk fatty acids. We've done some research to show that Jersey cows have more saturated fats than Holstein cows. We've also done a study showing that stage of lactation has an effect. So in earlier lactation, they're going to be producing more omega-3s than in later lactation. Parity also affects the milk fatty acids, and mastitis cases actually decrease the amount of saturated fats 16,0 and 18,0 and increase the amount of short-chain fatty acids. But all of these factors are kind of just minor factors in comparison to diet. That's the number one thing that you can do to change the milk fatty acid profile. About 60% of the fatty acids that you find in milk come directly from that dairy cow's diet. So if we want to improve milk fatty acids, that's what we're going to look to do, and that's actually one of the more easy things that you can do on farm. So here we have a study of fatty acids in organic versus conventional whole milk, and again I just want to note the difference between these systems is that requirement for organic farms to have 30% of their dry matter from pasture. So down here you can see organic is in white and conventional is in gray, and if we look at the graph on the left, we see that alpha-linolenic acid, that main omega-3 in milk, is higher in organic systems across the board in almost all areas of the United States. And so that then goes to the omega-6 to omega-3 ratio of being lower in almost all of the organic systems than the conventional systems. If you see all of the organic, as I said before, that 4:1 is our ideal ratio, so all of the organic producers are below that ideal ratio of omega-6 of omega-3 to of a 4:1. The one exception, as you might have noted, is California. So California systems often in both organic and conventional include a lot of fresh pasture in their diet. So that just goes to show you that a conventional farmer, if they're including a lot of fresh pasture in the diet, can achieve the amount of omega-3s that an organic producer has. So we did some research in Vermont on some organic dairy herds, looking at the amount of omega-3 and CLAs in milk fat throughout the season. So we enrolled 30 organic producers, and we sampled them from June of 2012 to June of 2013. I just want to note here on the y-axis you'll see that we're missing January and February because indoor diets tend to be pretty consistent. We opted not to sample in those months. So if you look at the fatty acids as percent of total fatty acids for omega-3s, they stay pretty similar through the summer months and then decrease as the cows move into that indoor diet, and then they increase a lot in that next spring. Which goes to show you that season can actually have an effect on these omega-3 fatty acids. And if you'll note, we have a high variability here among farms. So there are things that producers can do in management and diet to change the amount of omega-3s in their milk fat. CLA, we see a similar trend where you're increasing into the fall and then you drop off as they're feeding that indoor diet. And then again, you increase in the spring once they go back onto that fresh pasture. And just like omega-3s and CLAs, you see a very high variability among these farms. So there are things that you can do to change these milk fatty acids on your farm. And so from that data, I did a correlation of the omega-3s in the forages versus the omega-3 in milk fat. And the take home from this is that there is a positive relationship. So the more omega-3s you get in those forages, the more omega-3s you're going to get in the milk fat. So with that, I'm going to turn it over to Caleb, and he's going to introduce you to forage fatty acids and how to improve some of those.
Good afternoon. I hope everybody's got a little bit nicer weather than we do here. It's pretty cloudy. There we go. So if we're going to keep repeating that message about grasses versus corn silage and grain feeding. Just looking at the fatty acid profile of some common forages, you'll see these orchard grasses, ryegrass, alfalfa, red clover. They all have one thing in common, and that's that the majority of the fatty acids circled in that red box there as the 18-3 are omega-3 fatty acid that we're looking for, and it makes up the majority of the total fatty acid of those plants. And then the second really common one, well, there's two other ones. 16-0 is a saturated fat, and then 18-2, that's that omega-6. And then where we see the big change between those vegetative forage crops and corn silage is that corn silage has a very small content of that omega-3 alpha-linolenic acid and a very high content of the linoleic acid, that omega-6. And that's just because corn silage is 50% grain. So, you know, you've got your silage chop in the bunker, and you're really looking at a half by weight grain feed. So that's changes your omega-6, omega-3 balance a lot. And so there's not too much to do in that area apart from supplements to a TMR based on corn silage. So what we're going to talk a lot today on is the vegetative forages, grasses and legumes, primarily grasses. Sort of a throwback to high school biology. If you look at the bottom of our slide here, we've got a bilipid membrane, which every cell is surrounded by a membrane like this, and that's where a lot of these lipids are, and that's where they end up in you. And so for plants, one of the areas inside a plant cell that has a lot of these membranes is the chloroplast, and that's what's pictured in the middle here. And not only does the chloroplast have its own membrane around it, but it also has thylakoids, that's those futuristic-looking spheres in the middle there, and they have their own membranes. So suddenly you've got membranes packed in membranes, and if you think about how many chloroplasts are in a plant cell, it's just a good photosynthetic, oops, I'm sorry, I'm bouncing forward a bit here. There we are. A good photosynthetic leaf cell has a lot of chloroplasts, and so there's a lot more lipid potential there than I guess I ever would have guessed before I started studying any of this. That, you know, your lawn, there's a good amount of fats in those leaf blades. So as we look at increasing the total fatty acid content of the forage, and that's the x-axis on this graph here, you'll see that the primary driver of that is alpha-linolenic acid, that omega-3 fatty acid, the primary one in these vegetative forages. So big increases you see in the total fatty acid content are really just going to be big increases in this alpha-linolenic acid. And so there, in some of my future slides, I'll primarily present just the alpha-linolenic acid content because that really gives you a good sense of how much total fatty acid there is overall, as well as what the profile is, just because if you're going to see big changes, you'll see it in that alpha-linolenic acid. So in terms of how we can manage our forages for these ideal forage fatty acid contents, this is a meta-analysis done by some French scientists, and the way this data is presented is that the first and second column are effects on the average total fatty acid content as well as the average alpha-linolenic acid content. So that very upper leftmost one, the effect of haymaking, is that just by drying your forage and making hay, you're going to see a reduction in your total fatty acid content of about 2.4 grams per kilogram dry matter. And you'll see a bigger reduction as a percentage of those total fatty acids in alpha-linolenic acid. That main polyunsaturated fatty acid you lose faster than you lose the other ones. So you can see the good quality haymaking is a lower reduction in your alpha-linolenic acid content, and bad quality haymaking is a much larger reduction. So it's one of those things of, you know, you want to be making good hay anyway, but that's just another effect of your haymaking that it's going to be affected. We also see there is a gain in total fatty acid content with the process of just ensiling unwilted silage. That's not actually, you know, creating fatty acids from nothing. It's really just dry matter losses from the ensiling process. You know, so as sugars are respired, you have a lower dry matter, and it just looks like you have more fatty acids on a dry weight basis. And as we get into some more of the management factors that you have a little more control over, we'll zoom in here. It's the cutting date is another area where the earlier you cut, the less of a reduction you have. So, and that's of total fatty acids as well as alpha-linolenic acids. And that's, if we skip the crude protein one there, we go to regrowth interval, you see it's mirrored there as well. If you have a longer regrowth period, you have more mature forages. You know, you waited a little too long to get to that second or third cut. You again see decreases in the total fatty acid content and the percentage of that total fatty acid. That's the alpha-linolenic acid. So back to the crude protein. If your forage tests come back with lower crude protein, then you can pretty much expect that you're going to have lower amounts of total fatty acids and a lower percentage of those total as alpha-linolenic acid. So it's a little depressing to hear all these ways that we're losing our fatty acid content and we're losing our proportion of it. That's that omega-3 that we're looking for. You know, it kind of sets up a paradigm of, you know, how do you stop losing it? And that's really going to be just managing for good quality. But you also see at the bottom here, we do have one area that's been shown to increase your fatty acid content, and that's with nitrogen fertility. So an application rate of about 45 pounds per acre, not a total application, but for every 45 pounds more you apply per acre, you would expect to see a total fatty acid gain and a higher percentage of that being alpha-linolenic acid. Of course, that's all within reason. None of these studies are just continuing to add nitrogen. That'd just be a little crazy. But if you're wondering about, you know, whether or not to spend a little bit of extra money when you know you're going to get a better crop anyway, you might want to, just if you're worried about fatty acid content. So we've really kind of hit home that you want fresh, you know, early stage forages, and you want to maximize your grazing. That's the big difference between the organic farms and the conventional farms, is that the organic farms have more grazing. And we know our cool season perennial pasture might take a little bit to get going, and then we might see a summer slump, and then you graze as long as you can. So some of the strategies are really based about just increasing your grazing potential as much as you can. That might be planting a winter annual, like winter wheat, winter rye, triticale. You know, trying to graze. If you get it early enough, you might be able to graze it in the fall. If you have a fall like this one, you might still be grazing it now. And who knows, the way things are looking, you might be grazing into January. But if you can also have enough plant going in there into the spring, you might be able to get that grazing in before your perennial pasture really picks up again. What we've focused on a lot is the idea of using warm season annuals to also fill in that summer slump. Just our perennial pasture species, at least here in the Northeast, are primarily cool season grasses. They don't do as well in the hot and the dry of the midsummer months as a warm season grass. The C4 grasses like corn and pearl millet, sorghum, Sudan grass, teff, crabgrass. That's why your lawn goes to crabgrass in the middle of the summer. So by seeding these warm season annuals, it's just hoping to maintain maximum grazing potential throughout the midsummer. And I think we're going over to Melissa again.
Yep. I'm going to share with you guys some data from a study that we did 2 summers ago, where we included pearl millet in the diet of dairy cows in comparison to a diverse pasture. We did this on the Schwinyer family farm up in Highgate, Vermont. So what we did is we followed 8 Holstein dairy cows across the majority of the grazing season. So we started out in June, where we had fed a diverse pasture plus 30% of the diet dry matter coming from a baleage. So up here on the left we have a picture of what the diverse pasture looked like. It had greater than 15 species, with the majority of those 60 to 70% being grass species, 20 to 30% were legumes, and then the rest were forbs, about 10%. So they grazed that for 1 month in June, and then in July we switched them on to a pearl millet. So the pearl millet was planted on June 1st, and we grazed it around July 7th, so it had about 5 weeks to grow. And we planted it in succession, so we had planted one pasture and then planted one 2 weeks later, so that the maturity stage of the millet wasn't a factor. But as you can see here, our cows are grazing on the millet. It's about 3 feet tall, so it did get a little mature when we were grazing it. So just take that into consideration when I'm presenting these results. And then in August, we moved them back onto a diverse pasture. This time they weren't getting any supplemental baleage. All of their diet was coming from diverse pasture. And then in September, we moved them back onto pearl millet. We replanted and again grazed it at about 5 weeks of growth. And we took samples weekly, but I'm just going to present data from the last 2 weeks so that the treatment kind of had time to have an effect on that milk fatty acid profile. So first off, I'm going to show you the forage fatty acid profile. Sorry, we're going to talk about production first. So as far as milk production goes, our first graph here on the left is just milk in pounds, and there was no statistical difference between treatments. You can see there is a numeric difference where it seems like in the months of July and August, cows produced a little bit less milk, but that's probably due more to season, where those July and August months are hotter, so cows are experiencing a little bit of heat stress because both treatments in the cooler months of June and September were higher, and again there was a high variability between cows, so none of this was statistically significant. Fat percent, again, no difference between the millet and the diverse pasture. It was right above 3% for the whole grazing season, and same thing with protein percentage. No difference between the two forage types, right around 3% throughout the months. Now we're going to go into forage fatty acid contents. So we looked at the omega-3 fatty acid content of these forages, and there is no difference between the omega-3s supplied by either the diverse pasture or the millet. So going in, they had equal amount of omega-3s available for milk fat synthesis. So if we look at some of the fatty acids we see in milk, over on the left we have a graph of saturated fatty acids. So we had the highest amount of saturated fatty acids when they grazed the diverse pasture, plus 30% of their diet as baleage. And now, as Caleb mentioned, you lose those polyunsaturated fatty acids in conserved forages faster than you do saturated fats. So that's probably why we see a higher amount here, is because that baleage has a reduction in those polyunsaturated fatty acids. Millet had an intermediate amount on both treatments, and we saw the lowest amount of saturated fats when we grazed only a diverse pasture and didn't supplement anything. If we look at CLAs, we see the opposite effect, where we have the most CLAs when we grazed only that diverse pasture. And we actually have the least amount of CLAs in milk fat when we include about 30% of the dry matter as baleage. And again, that's probably because there's not as much polyunsaturated fatty acids in the diet for those rumen microbes to modify to CLA. Millet had an intermediate amount. They were different between the treatments, but just kind of an intermediate amount between supplementing baleage and grazing a diverse pasture. Now, if we look at those omega-3s in the milk, we see, again, the highest amount of omega-3s when we graze the diverse pasture and don't supplement anything. We see the next highest amount when we graze a diverse pasture and supplement a little bit of baleage. And we see the lowest amount in that millet. No difference between those two treatments, and almost about as half as much in the millet as that pure diverse pasture. And then accordingly, the omega-6 to omega-3 ratio is then higher in the millet than it is in the diverse pasture. But I just want to call attention to this x-axis, that the ratio here is below that ideal 4:1 that we were talking about. So both ratios of omega-6 to omega-3 in milk on these diets are very good. So I converted these numbers into the amount of milligrams you would see of these fatty acids in a serving of whole milk. So here we have about 66 milligrams of omega-3 when cows were grazing diverse pasture and a little bit of baleage. We have about 43, 44 when they're grazing millet. And we have, again, almost twice as much when they're grazing only a diverse pasture. In CLAs, again, we see it follow that it's highest on that diverse pasture in August, and then we get an intermediate amount when they're on millet, and the lowest amount there for CLAs when you include the baleage. So the Institute of Medicine of the National Academies recommends that women have 1.1 grams per day of omega-3s and men have about 1.6 grams per day. So if you had 3 servings of milk from cows on this diverse pasture that we grazed, that would contribute about 0.2 grams to the daily intake, or about 1/5 for women to about 1/8 for men. So that's a pretty big contribution by milk fat if you consider what it represents calorically in our diet. And there's no recommendation for CLA. It's not essential in our diet, but it is something that consumers wish to consume. So again, that was highest in the diverse pasture, just only diverse pasture. So some take-home messages from this study. Grazing a pearl millet versus the diverse pasture didn't have any effects on milk production, milk fat, or protein percentage. So if you do need to increase the amount of dry matter that your cows are consuming in the summer months, then this doesn't have any effect on production. It's not going to increase or decrease. Content of omega-3 fatty acids and CLA were highest when cows were grazing only a diverse pasture with no supplemental baleage. So if you're really looking to optimize your fatty acid profile, then diversity is key, and getting it all from the fresh pasture is really important. So our current research is looking into the rumen microbes because, as you might have noticed, the amount of omega-3s in these forages were the same across the board, and yet somehow we saw twice as much going out in milk of the cows on the diverse pasture versus the millet. So there are these things called tannins that are usually contained in more diverse mixtures of pastures that can inhibit the rumen microbes that modify those omega-3s into the CLA intermediates and finally the saturated fats. So we might have more of those or different types of those modifying the rumen microbes, and if we can kind of figure out that link, then maybe we can figure out additional strategies to improve the fatty acid profile. And of course, if we just improve the amount of omega-3s in general, then we will theoretically see more omega-3s in milk fat. So I'm going to throw it back over to Caleb, and he's going to go over some strategies that he found to improve the amount of omega-3s in some of these summer annuals.
Okay, so my experiment, I'm not sure if I think we're coming up on it here, was looking at 2 different species of summer annuals. I was looking at pearl millet and Sudan grass, and we used 2 sites. A deep sandy soil site, sorry, speaking a little fast, a very sandy soil site at the Hort Farm here at UVM, and a silty loam soil site in northern Vermont with a little bit more native fertility. I was doing 4 nitrogen fertility treatments. 35 pounds of nitrogen per acre was applied to all of the plots as sort of a base treatment, and that was composted chicken manure, and that was just to make sure everything had enough phosphorus and potassium. And then the plots that received increased amounts of nitrogen, 70, 105, 140 pounds per acre total, that was provided as Chilean nitrate, just to have a really soluble source of nitrogen to make sure the plants were getting it and we could see the effects that we might have. And these fertility treatments were also repeated after the first cutting. So, 140 pounds of nitrogen per acre and then doing it again before the second cutting, clearly that's not what I'm recommending. It's just for the research purpose to see what effects we're having on these species and the forage fatty acid contents of them. And I did 2 harvest regimes. I had sort of a simulated pasture where I was harvesting at about 55 centimeters, or roughly about when it came up to my knee, which is when you would want to be grazing these summer annuals, or when you would want to begin grazing. And then I'm having quotation marks here for a reason, the conserved cutting, which I didn't actually ensile, because as we pointed out, ensiling is going to change the fatty acid profile. So just to see what's happening in the plant as you let it get to that maturity stage. So harvesting at a height of about 85 centimeters upwards, so waist height for about a 6-foot person. And I collected the yield data. I did the fatty acid content and profile of these samples, looked at regular nutritive quality with our NIR here at UVM, and then I constructed a leafiness measure where if you look at that picture with the scissors at the bottom, you can see I was cutting off the leaf blade right at the ligule where it meets the sheath of the plant. And on the picture to the left of that, you can see leaf blades and the stem, the pseudostem, the leaf sheath portion. And I just took the dry weights of both of those and made a ratio of the leaf blade relative to the entire tiller. And I also measured chlorophyll with the handheld SPAD meter, which is the device you see on the right. Just because it's quick, it's easy, you get a good number to associate with the greenness of your leaf. So I also have a picture here just to show you the difference you see with the fertility treatments. This is the first cut prior to harvest, obviously. On the left you see Sudan grass with 140 pounds of nitrogen per acre, and on the right you see with the lowest rate at 35 pounds of nitrogen per acre. And you know, it doesn't take much to see that the one on the left looks better. A lot of people are also maybe trying to incorporate these summer annuals into their rotations as a way to rejuvenate old pasture. And you can see that if you don't have that optimum fertility, if you're looking more like the side on the right, you're letting a lot more weeds grow up. I don't know if you can see it, but there's white flowers coming through, and there's a lot of crabgrass that's sneaking in there. So, you know, that's the reason why organic veggie farmers are using summer annuals as cover crops, because you're getting a bunch of biomass and you're choking out weeds. If you don't have optimum fertility, you don't get quite those same benefits, so you're just not getting everything that you maybe could. Now, as we get into our fatty acid results, here's a look at the total fatty acids. And the blue bars are my supposed pasture samples, and the tan bars are the conserved, so basically short and tall. And you see reductions in the total fatty acid content from the first cut to the second cut. So the first cut is the best shape. And then you also see that that reduction is a little bit more pronounced on the sandy soil location. I think that summer we had some drought stress, and I think those plants didn't quite, they maybe by the time they reached the height to sample, they were already trying to go a little reproductive, so they were maturing a little bit more, and they also were potentially losing some lower leaves due to the drought stress. As we look at that primary omega-3 fatty acid, alpha-linolenic acid, our yellow bars are pearl millet, and our blue bars are Sudan grass, so we broke it up into species here. You can see the pearl millet has the bigger reduction from the first cut to the second cut, and you can see that the Sudan grass only really has that second cut reduction in fatty acid content on the sandy soil location. I think the pearl millet, you know, that first cut, that primary growth of the pearl millet, if you've ever grown it, it's very leafy, but by the time of the second cutting, you're getting regrowth, and it does look a lot stemmier. So that, I'm guessing, has a bit to do with it, as well as just reductions in content due to later season effects. If we look at the same species just by the height at which they're harvested, the pasture versus conserved, you see that it's a most pronounced effect is at the sandy soil location. And again, I think that's a lot to do with the drought stress. So if you have good-looking plants, and you may be able to get away from some of these reductions. And then when we go to the fertility treatment, looking at it by nitrogen, you can see that there are maybe not big gains, but they're noticeable gains, and that the lower levels of nitrogen fertility really are producing lower amounts of total fatty acids and this primary omega-3 fatty acid, the alpha-linolenic acid. You can see that these gains from the fertility are most pronounced in the shorter height plants, the pasture samples, and that you kind of have diminishing returns with your taller plants. So if you're maybe using these to chop and put up, you don't see quite the same increase with increasing levels of nitrogen fertility, but at the same time, I don't show the data here, but you don't see quite the same yields either. So really, you just have to have optimum fertility. You can't skimp on these summer annuals. They love their nitrogen. You know, these lower rates, as we'll see as we look at just a shot of some of the plots, produce a visibly inferior plant. You know, these are just pearl millet and Sudan grass, and the only other differences are the fertilities that they're growing under. So just visually, you don't have to send your samples in for fatty acid analysis. You can see which ones are leafy, which ones are looking healthy and dark green. But you know, you got to think about, with these plants, it's not like ryegrass or something like that where it's all leaf blade. These have a lot of pseudostem where you've got leaf sheath, and then the closer they get to flowering, they're going to have a lot more of culm and pseudostem material. It's diluting the fatty acids that you're getting from your leaf blades. So I'm going to point out my error on this slide that we just saw this morning. At the very bottom of this table, it says omega-6 to omega-3, which is the way we often present this ratio. However, when I did these statistics, I had actually done it as omega-3 to omega-6. Keep that in mind. But many of the common correlates that people use to kind of gauge forage fatty acid contents are along the top here. We have crude protein, ADF, NDF, and etc. You can see that the biggest predictor of total fatty acid content is NDF. So as your NDF is increasing, your fatty acid content is decreasing. That makes sense. You know, more NDF with more maturity, and therefore less total fatty acid on a weight basis of the forage. Same thing with the polyunsaturated fatty acids, because they make up your majority of your total fatty acid content. And crude protein is a good indicator of alpha-linolenic acid. You know, crude protein is almost a proxy for the leafiness of your forage. You're going to find the crude protein from the leaf blade tissue the same as you are the alpha-linolenic acid. It's really associated with your chloroplasts. And then my computed measure, where I combined my measure of chlorophyll and leafiness, has a pretty strong negative correlation with linoleic acid. That's your omega-6. So as you have more dark green and a higher amount of leafiness, or maybe that's better said as a more dark green and less stem relative to the entire plant, you're going to have less of this omega-6 on a percentage basis of your total fatty acids. And then you're also going to correlate that dark green and very leafy with a higher omega-3 to omega-6 fatty acid ratio. So ignore our label on the left there. But similarly, it's the same as an omega-6 to omega-3 fatty acid ratio, but it would be a negative correlation with that. So our take-home message, our summary really, is that you want to maximize your grazing. And if you can choose, if you have the ability to choose species that have greater leafiness, ryegrass is a really good example, just because it's almost all leaf blade. That's a great thing to choose. You want to optimize your fertility. You don't have to go crazy. Increasing levels of nitrogen are going to end up just as diminishing returns on your costs. And you got to manage for quality, same as good crude protein content and good sugars. High quality forage is going to be high quality for fatty acid content as well. If you're doing meat, you want to reduce your grain finishing. Just the longer they're on grain, the more you're giving them omega-6s, and you're changing that omega-6 to omega-3 fatty acid ratio. And if you can, supplement with PUFA-rich feed in winter. So that's your polyunsaturated fatty acid-rich feeds That will help you through those winter months where you don't have the fresh grazing, and that could be the best case scenario is that you're putting up really good conserved feeds, just high quality haylage, baleage, and things of that nature. And some people get into supplements, and Melissa has a warning for you there.
Yep. So I know some farmers that were thinking about experimenting with flaxseed, and there have been studies that show that flaxseed can really increase the amount of ALA in milk fat. It just depends on how you feed it, whether or not it's whole or extruded, and the percentage of dry matter that you feed it at. And you have to be careful there, because if you go over a threshold and feed too much, you can see a milk fat depression and a reduction in your fat yields. So if you want to try experimenting with maybe supplementing with some flaxseed over the winter to kind of keep your fatty acid profile where it generally is over the summer, then definitely try to consult maybe a nutritionist or someone else you know who's had success with this, because you can kind of have some detrimental effects to your milk fat production. So with that, we'd just like to acknowledge some people that helped in our research and our advisors, if it'll go. There we go. And of course our funding sources, and we would like to thank you all for attending, and with that we will take any questions that you might have.
Great. Well, thank you, Melissa and Caleb. That was really great. I love the combination of agronomy and nutrition and animal science. It's very, very exciting. So thank you. All right. So we're going to move into Q&A now. Oh, boy. That's a nice OSHA-friendly slide.
Was staged.
Good. Good to know what we do to graduate students. Okay. So we do have quite a few questions in the question pod right now, so I'll just go launch right in. One of the first questions we got was you were presenting, Melissa, and there was a question about the relationship between omega-3s specifically and methane production. Did you all study that or have any information about that?
That was
Go ahead.
Nope, that was not one of our objectives to look at the methane production, but there has been quite a bit of research on that. There are several people that have supplemented flaxseed and soybean oil to see if they have any reduction in methane, and that has shown that there is a reduction. As I said, if you increase the amount of polyunsaturated or omega-3s by every 1% you increase that fat in the diet, you decrease methane production by 6%. I believe Andre Brito did some work with methane production and flaxseed, and he's got a paper out on that. I think Kathy Soder was a collaborator. So there's definitely literature on that, but that wasn't one of our main objectives.
Okay, great. Do you have any information on how parity might affect milk fatty acid profile?
Yes, so parity does affect milk fatty acid profile. I don't have the specific fatty acids right now. I believe it was oleic acid. I can't remember whether or not it was higher or lower in multiparis versus primiparis, but that's a monounsaturated fatty acid that you see in olive oil. There aren't any direct health links, but monounsaturated fatty acids in general tend to be very good for you.
Okay, great. Continuing on, Melissa, and we'll get to you, Caleb, too. But in your feeding study, were the cows fed any grain, or was it just diverse pasture? And
they were fed a little bit of grain. They got 6 pounds a day of grain.
Okay, and then in your same study, there's a question about the quality of the baleage. So they ask, was the baleage of good quality, less good quality, or poor quality?
It was of good quality. Ghee puts up very good baleage. I don't have numbers on the top of my head of ADF, NDF, crude protein. We do have that data. I don't know if there's any way, if that person who asked the question wants to email me, feel free. I can definitely get you that data of what the forage quality of his baleage was.
Mm-hmm. And I can follow up by exchanging those emails if you'd like.
Okay.
Caleb, you talked about NDF. what does NDF mean?
Oh, good question. NDF is a measure of the fiber in the forage. So as the plants get older, there's going to be a greater concentration of these fibers, lignin, and so a more mature forage, as it's heading towards heading out and putting out seed, tends to have a higher NDF value. And so that's a very common parameter for forage crops, of just to judge quality in general. Typically, you're trying to shoot for a lower NDF because that means a younger plant or younger maturity, and it's higher quality for production on the animal front.
Great, thank you. Do either of you know if pasteurization changes the fatty acid profile?
It does not. They have done studies to show whether or not raw milk versus they did ultra high temp pasteurization and then the normal pasteurization that a conventional milk would use. So I don't know if our listeners know, but organic milk is always usually ultra high temperature pasteurized, and then conventional milk is generally just normal. Organic uses the ultra high temperature pasteurization, conventional uses normal pasteurization program. And then, of course, there's raw, and there's been a study that shows that there's no difference between the fatty acid profile of those three pasteurization types.
Okay, while we have you, Melissa, I'm going to continue on with some of your study.
Okay.
Did you see any signs of toxicity? Oh, I'm sorry.
No.
Yeah, okay, go ahead. Yeah. I'm going to ask that same question to Caleb.
Okay. No, we did not see any sign of toxicity with the millet. I don't think millet has ever been seen to be toxic to dairy cows. I don't think they have anything that you have to worry about. And do you have the same question for Caleb?
Yeah, but let me ask you another question first, and
Okay.
then, because I know you're sharing the headset now.
Yep.
During the experiment, why did you select a pearl millet?
Because we were geese junior, we decided my connection's back. Because he was good enough to allow us to do the study on his farm, we talked with him and I think gave him a few options as to what he wanted to do, and he was the most interested in including the pearl millet as a summer annual in the pasture.
Okay. So now we have a couple of questions for Caleb, and I think you're both on now.
Yep.
Oh, great, Caleb. So in terms of toxicity, did you see any toxicity on the Sudan grass during your study?
Right, so I wasn't actually measuring those parameters. You do have potential for like nitrate toxicity, and with Sudan grass, I think you can also get prussic acid poisoning, but that's pretty rare, and there's some general things that just a really quick look at most extension fact sheets on these summer annuals can give you all the info you need to not run into those problems. But a lot of it is not grazing after a freeze, and with nitrate, you have to be a little careful. If there's an extended dry period, you don't want to let the cows graze too low, because the plant might be accumulating nitrate down at the base of the plant. But I wasn't actually testing my samples for those parameters.
Okay. And to you, the same question, why pearl millet and Sudan grass versus other forages? Was it for consistency across your two studies, or?
That was actually just coincidence. Pearl millet, that variety is just a nice grazing one that a lot of people like. It's very leafy and similar with the Sudan grass. And then, one thought was we almost did a sorghum as well, but Sudan grass and sorghum are very similar, so just to keep the number of samples to a manageable level, we only did 2 species. What I probably wish I had done would be some other warm season annual like teff, which is a somewhat rare around these parts annual that's a bit lower in stature, so it's a little leafier. I'd be curious to see, how much of these effects were the fact that there were summer annual plants, and how much of it was really just the architecture of the plant, and how much was leaf blade compared to the overall plant.
Gotcha. Cool. One of you, I think it was Melissa, mentioned tannins and tannins connection to fatty acid, and I'm just curious about that diversity of the pasture. Some of the pastures here in Vermont have bird's foot trefoil, and I know there have been a couple of other projects conducted recently across the country on bird's foot trefoil. So I just wanted to get sort of your thoughts on tannin-containing forages.
Yep, bird's foot trefoil is definitely the hot one that a lot of people have looked at because that is known to have a lot of tannins in it, and that's definitely the one that we see in the Northeast here a lot. Juan Alves was a collaborator with us, and he has went out into the pasture and walked through and looked at and recorded every single species that he could identify in the pasture. And I believe he said he was giving a webinar in January on the same millet study that we did. So he's got the data of other species that might contain tannins that were out in our pasture. And again, I can get that data to that person if they want.
Yeah, and just as a reminder, yes, Juan Alves, who's a researcher here, will be giving a webinar on eOrganic, on biodiversity of pastures and the microbes in the rumen and their connection to livestock well-being, and that's going to be happening January 14th. So we'll make sure that you all get an invitation to participate in that webinar as well. Okay, so there's another question in the question pod here that says, do you have any information or interest in conducting research for dairy or meat goats?
Yes. So meat goats I'm less familiar with. Dairy goats, you're going to see a very similar effect as far as changing the profile of the forage is going to change the profile of the goat milk. Goats in general also tend to have a little bit more shorter chain fatty acids, but you would see the same effects in both goats as you would in cows. Great. And I'm assuming you would see the same effect in the meat as the milk. I'm just less familiar with goat meat.
Okay, great. I think that's all the questions we have in our question pod now, but I want to just give a few seconds. If people have any last questions, you can just type them in. Again, just pop on that question mark if you're on a mobile device, or you can click on that question box, type it into us. We'll just give a few seconds. I don't want to keep people if they're satisfied. Oh, here we go. Okay, if a farmer is feeding a diverse pasture mix and not getting CLA results, what would you recommend they do to change it?
If you're feeding a diverse pasture and you're not getting any improvements in your CLA, then you are not getting that omega-3 into the biohydrogenation process, that modification by the microbes. Either that or that CLA is being too rapidly modified by those rumen microbes. So it would either be, again, to look at the forages in your diverse pasture. Maybe if you have a lot of bird's foot trefoil, then a lot of omega-3 is getting through and not being converted. You could also look at the omega-3 content of your forage in general. Maybe it's not that high, so a lot of it's not getting modified. So yeah, look at the amount of omega-3 in the forage, what species are out there, if they're containing tannins, and then the other thing would be the rumen microbes. It's kind of an unknown right now, but if you could modify those rumen microbes to try to get the ones that aren't doing the full biohydrogenation process, then you could improve your CLA.
Great. I think that's all for questions. So I'm going to just wrap it up here. I want to thank Melissa and Caleb so much for joining us today. It was really good presentation. I'd also like to remind you, our audience, that the recording of today's webinar, as well as all of our other webinars, will be posted or are posted at eextension.org /organic_production, and you can also see the website up there. If you have another question after the fact, you can just ask us at that ask.eextension.org. And any of our other articles, videos, and more are also posted at our website as well.